Hey guys, another video for you today, and this time we've got a realistic TRC 449 mobile radio. And yep, she's been modified, but not for long. Actually belongs to somebody that I know, and he asked me to demodify it. He just bought this one recently and he wants her put back to stock, which is what I intend to do with it. And then I picked up a scanner today. It's a old Pro 35 100 channel handheld scanner. I had one of these when I first got into the radio racket way back when, back in the late 90s, and had a chance to get another one today, and there she be. Her battery pack is kind of messed up. Whoever head scanner broke off on this part of it. There's a little plastic part goes under here, like a clip sort of thing, and it's been sheared off, so the battery no longer sits tight. The battery needs to be redone anyways. The battery's shot on it. It needs a new battery, or rebuild the battery I should say. But anyways, so yeah, just want to show you the scanner as well as the 449. There's a couple little doodads that I got, and like I say, this one is going to be demodded, and I'm going to show you how to demod a TRC 449, because apparently this one's got like 1, 2, 3, 4, it's got 5 bands on it. They've got switch mounted at the bottom of her right there. And then they've got a band switch put on her RF gain control, and the meter is bad in her. The owner may supply me with a new one, we'll have to see. But yeah, we got to put this thing back to normal. I hate it to even look at this to see what it looks like on the inside. Anyway guys, I'll talk to you in a bit and catch you later. Alright guys, I'm going to demod the 449, and this is what it originally came with, or I should say modified with. They've got the noise blanker messed with, so that's got to be repaired, put back in working order, joy or bliss. And then they've got this rotary switch put in that controls A channels and God knows what else. So, yep, I'm going to take all this crap out of her and make her a regular 40 channel radio again. And here we are. One switch right off the bat. It's got to be removed. I've got audio lines here. A couple of wires down there cut off. I've got to put them back on. That's the rotary switch there that's now replacing the RF gain. So I've got to get another control to put there to get the RF gain working again. And let's take a look at the PLL side. And here's the PLL, UPD858 PLL side. So we got to remove all of this crap that's put on here, and put her back to 40 channels. So that's what we're up against. A massive amount of wires, a switch, well, two switches, reinstall the RF gain control, and get the noise blanker switch working again. So there we go. Why would anybody want to destroy a radio? And they even got the front of the radio all scratched up trying to put that stupid switch in there. And they got the front panels coming off. It's a real scene to get done to the radio. Anyways, let's see if I can't doctor her up and see what happens here. Oh Looks like the transmitter has been mucked with a bit. The slugs have been messed with a little bit. Anyways, that's it. So, for part 3, very shortly. Right guys, here's part 3. I've already went ahead and removed one switch from the radio so far. And I was wondering why this was actually loose. Now I know why. Because in order for them to mount their little switch here, they had to remove this fascia in order to mount it, in order to access the nut, in order to tighten it. So I had to do the same thing, remove it. Anyways, let's get this switch pulled out, cut some wires clear, shall we? Okay guys, the switch has been removed. The band switch has now been removed from the radio. Still got a couple of wires here to contend with, but that's not here nor there. Got a couple of resistors here left to take off, but the top of the UPD858 chip is looking normal. Again, let's just hope that the PLO chip is working normal. But we'll see very shortly. So far, 2 switches have now been removed. Let's carry on. Alright, as you can see, now I got the faceplate completely taken off the radio, because now I got to resolder some wires back on the original noise blinker switch. And in order to do that without having to burn everything up, is to take the switch out, wire it up, and then remount it back in there where it's supposed to be, tighten everything up. So that's where I'm at now. Now I got this brown wire here. I gotta solder that on to the bottom 2 pins on the switch, which is according to the diagram for the noise blinker switch right there. So that's how I got to wire up. I got 4 wires. I got that big brown one, audio wire, say, and then I've got that red or pink and the brown wire, which got to be soldered to 2 joints on the board, one right there in the center of the screen, and then I've got to follow this and make another connection right there in the center of the screen. So, think of our service manuals. Helps to rewire radios if they've been tampered with as much as what this poor 449 has been. So anyways, we'll get this wired up and I'll get right back in. Hey guys, got the faceplate put back on, the LEDs put back in their places, and the switch is now rewired down there. Noise blinker switch is now put back the way it's supposed to be. So all we need to come up with now is a 100K potentiometer to hook up the RF gain. Also had to fix a few solder joints on the PLL chip. I'm not going to show which positions or what they're on that, but you get the gist of it. So now we're going to wire up these 2 to the RF gain control, and then we're going to see if the radio survives this ordeal or not. So stay tuned, we'll be back very shortly. Alright guys, I got the 449 redone there. I got the RF gain control resoldered. I got noise blinker switch put back. In all intents and purposes, the radio should now be a straight 40 stock AM SSB transceiver. The only thing to do now is to test her against the Macoba 139. Make sure all 1 to 40 is working on this one, along with the, make sure it's working with the 139. Anyways, let's give her a test and make sure everything is working like it should, shall we? Well guys, I just tested the radio. She's now working on all 40 channels, 1 to 40, upper, lower, and AM. Although the channel display is rather bad on her, as you can see. And the dimmer control ain't doing anything. So the circuit is after failing, which is probably a lower voltage now feeding one side of this display from the other, which is causing her to go screwy. And as we all know, we need a 5-volt regulator to put in there to fix up the circuit. And the circuit is down in this little corner here. Anyways, for all intents and purposes, the radio is now working on TRC 449. Back to stock. And let's put her clothes back on. Hey, well guys, I hope you enjoyed the video on demodding the 449. It was a bit interesting. It's the first time I actually got into a radio now in a long time. You know, hobby wise. I'm at it all the time while I'm at work repairing radios, and I may start doing a few videos while I'm at work too. We'll see how that goes. I'll have to get permission first, but I'm sure that won't be a problem as long as I don't interfere with the time it's going to take to do stuff. But we'll see how it goes. Anyway, radio is now working from 1 to 40, working as it normally should, minus these two switches, and now noise blinker works like it is supposed to. RF gain is working like it should, and the radio is now 100% stock again. One thing it needs to do now is replace the meter. As you can see, the needle sticks, but without a proper replacement, there's no point of even changing that out yet. And also got to fix the regulator circuit for the display. And I'll leave it up to the owner, see if he wants to do that. Hey guys, well, I said another video. We're going to try to get another video up on the 449. And tonight looks like we're going to do as you know, the 449 is supposed to have a dimmer control, which dims out the LED display. So when you rotate this there knob on the inside, that there LED should dim out. Just rotate it and see what happens. Absolutely nothing. And why is that? Because the circuit that controls the brightness or the voltage to the display is malfunctioning. So let's peel this bad boy apart and let's take a look at that circuit and see where the fault may lay, or may lie, or whatever. Anyway, let's unbutton her. Okay, if you guys were following my other videos that I did have uploaded here on YouTube about the Cobra 139 XLR, the Cobra 138 XLR, the TRC 458, the TRC 457, the videos I had put up when I completely rebuilt those radios. You'll know that the voltage regulator that controls the LED display is down there, especially for the 449. You can just about see her. See if I can't point her out there for you. She's right there, right at the bottom of that screwdriver. Right there. That's a 5-volt regulator right there. And that controls the 5-volt circuit that lights the LED display, and the dimmer also works off that same circuit. So we're going to check that regulator and see what it's doing, if it's doing anything at all. So let's put the radio over on our solder side here and do a couple of voltage checks on the regulator. And the regulator is right there. So let's see what that's doing or not doing on the voltmeter. Okay guys, I made a little mistake. The 5-volt regulator I pointed out is actually for the PLL. Excuse me, but I've been out of the actually, no, I'm right. Jesus Christ, I've gone mad by. It's an 8-volt regulator, a 5-volt regulator. It takes 8 volts from the circuit and feeds 5 volts back. So the transistors that actually control the dimmer, which is right here, would be Q37 and Q36. So Q37, this one here, is the one we're checking there now. And there should be 1.63 volts on the emitter. The collector should be grounded, and the base should have roughly 12 volts. So let's check and see what's going on with the voltages. And the transistor, if you're looking at the solder side of the board, the transistor is located right ahead of this here resistor. So that's the 3 pins there. You got this one, and this one. 3 of these here. 1, 2, and 3 are for TR37. So we're going to check the voltages while trying to adjust the dimmer and see if the voltages are the same or if they're completely different than what's marked here. So let's check the voltage going to the base right now. Go to the base and to the what the hell am I saying? Look at this all mixed up. Oh, me nerves. The base right here should have 1.63 volts. The emitter should have 12 volts on it. And that's your collector. That's the base, that's the emitter, base, collector. So it's 1.63 volts on the base and should be 12 volts on the emitter. Now we got it right. Oh, me nerves. They're hard to tell I've been out of this for a while. So. Anyways, let's check the voltages on the base and emitter and see what we got here. Alright. Let's see. Let's probe for 12 volts. See what we got here. Got nothing there. We got nothing there. And we got 3.3 volts there. That's 3.3 volts. That trace should be supplying at least 12 volts. Let's try selecting changing modes. I doubt it's going to affect anything, but let's see anyways. So we definitely got a 3.3, so we've got a drop. We've got a drop going on here of about 10 volts, because that's supposed to be 12. And we'll just move the dimmer control. That's all the way anti-clockwise. And that's all the way clockwise. As you can tell, there's no change. The other trace or pin that should have voltage on it is actually showing no voltage at all. That's the other 2 pins there. One obviously is your collector, and the other would be the base. And the base do not have voltage. So then, the base don't have voltage. So if the base don't have voltage, that means the dimmer control don't have voltage, which means obviously the dimmer control does nothing. Alright, so we know the base on TRC37 has no voltage. TR36 will be located right there, and it's a 2SC1419. We do know how much these guys likes to blow up. While checking the circuitry, I noticed a charred resistor burned up. R197. Barbecued. So, looking at the schematic for the radio, we find that 197 is actually located right there, and it's right on TR36, which is located right there. So we have another voltage regulator problem. Chances are TR36 is shorted out. It's the ground for the display. It's either TR36 is shorted out, which I'm thinking is possible. Is quite possible, or TR37 is shorted out. One of these is after shorting out, which is after causing our 197 to take a huge current load and burn itself to bits, which effectively is disabling the dimmer control, which in turn is making the display look like it's got issues. Believe me, it has issues. So we have to get ourselves a new transistor to put here. I'm going to get a new transistor stick here. I'm also going to get, because it is quite warm, you can actually feel it quite warm. Quite warm there. Got to replace that one. I've got to replace R197, which is, where did I say that was? Oh yeah, right there. And also TR37 down there. So I got 3 parts to replace in the radio right now, and see what's going on. Let's see if TR36 has 13 volts on it. It's supposed to be right there on its collector. Should be 13.2 volts on the collector and 1.6 on the emitter. Let's just see what TR36 is doing. Alright, I'm going to probe TR36 there now. There should be 13, one of those pins should show 13.2 volts. So I'm going to start on the bottom, close to the board. We see 3.3. Now you know we're at voltage, you've seen that before, haven't you? You've seen it on TR37. Alright, so let's check the center pin. We have 0 volts on the center pin, and the top pin is showing 2.6. So we know the 13 volt rail is being drawn down. There's a lot of current on the 13.2 volt rail. So we have to find out if it's actually what am I keep saying TRC? TR36 is what's causing it, or something along the 13 volt rail. So let's check the 13 volt rail and see what's also in line with that. So 13 volt rail is right here, and it comes down. So we're following this line. I'm going to get this green going. There we go. It goes across. Aha! You see what I see. a Zener Diode D44. How many times have I said the Zener diodes in these radios is retarded? They keep shorting out. That would definitely cause a 13 volt rail to drop to nothingness. 13 volt rail. It also gives voltage to the power amplifier circuit for the RF power. So the RF power is probably very low, if it's anything at all. Let me do this, I'm going to get lost here. So we're coming over here. The 13 volts also got to be fed to the 1156H audio amplifier as well. You can also see this, another power supply circuit right there. Another Zener Diode D25. So we've got a bunch. We got D25 that possibly could be shorted out. We have D44, which is possibly shorted out. We've also got the capacitor C101 over here. Electrolytic capacitor could be shorted out. So yeah, the radio has a few issues, to say the least. The first thing we got to do is see where the 13 volt rail is being drawn down. If it's being drawn down on the Zener diodes, or if it's being drawn down on that 1419 regulator chip right here. So what we got to do is disconnect this little puppy and see if the 13 volt rail comes back up in voltage to where it's supposed to be. Interesting, isn't it? God, I love these boards. Alright, just check the voltages on TR36. The collector do have 13.2 volts. Actually, it's 12.9 volts to be exact. So that part of the circuit is functioning. So it's the emitter side of TR36 that is shorted out. There's a problem, not like shorted, but there's a problem with either the base or the emitter on TR36. The emitter for TR36 just goes straight directly to the display. There's a very high current load going on the emitter, because it caused R197 to burn up. So, the first thing we have to do, we've got to change out that TR36, which is a 2SC1419. And if I'm not mistaken, I believe the cross-reference for 1419 is a NTE152, if I'm not mistaken. I could be mistaken. It's been a while. I think it's NTE152. But let's just check it anyway and see what the cross-reference for 2SC1419 is. Okay, doing a cross-reference on the NTE website. We find out that the 2SC1419 is in fact cross-reference to an NTE152, which I thought it was. So I am correct. See, I do still remember things. Anyways, I gotta see if I can dig myself up a NTE152. I wonder, in my junk box, do I have one? I guess we'll have to find out. Anyway, stay tuned, guys. I believe this repair is going to get a little bit more finicky. So, thanks for watching and stay tuned. Sound boys, all the best. Alright guys, demodding the realistic TRC 449, part 5. Starting to turn a pretty interesting little repair. Supposed to be just a simple demod, but turned into some other problems. But anyways, let's do a quick refresher as to what's going on here. We have resistor 197 down here. that has cooked itself. We have TR37 down here that could be bad, and we've got TR36 over here that is probably the culprit as to what's going on here. 2SC1419. And these items are located right there. TR36, 2SC1419, TR37 is a 2SA719, it's a PNP, and of course the resistor R197, which is 33 ohm. So what we're going to do, I've got a new 33 ohm resistor, quarter watt resistor to replace R197 with, and I also have a new TR36 courtesy of the Jedi in Ireland. Sent it over last year, I believe it was. These are the two items that's going to be replaced. You got that 2SD235, which cross-reference to a NTE152, and of course the 33 ohm resistor to its left. So we're going to replace two of these parts first, and if these test okay, then we're going to see what the display looks like. And the display is back to normal. Then and the dimmer is working. Chances are TR37 is also going to be good. So let's replace TR36 and R197. Alright boys, there's the two bad parts. Resistor, 33 ohm resistor, cooked beyond recognition, and the 2SC1419 transistor. Now replaced. I got 2SD235 put over here, and I got the 33 ohm resistor put right here on this side of the board. So if it ever burns up again, you don't have to worry about cooking any wiring, because it's pretty. There's a couple wires here, especially this black one got a little bit charred, a little small bit. I don't want to risk burning that wire any more than what it is. So I've replaced the wire, or the resistor, to this side of the board. So what we got left to do now is power up the beast and see if the dimmer control works now or not. So let's get some power to her. Alright, let's check the voltages now. That's the bottom pin. Now I'm advancing the dimmer control. Top pin. Center pin. As you can see, I believe the dimmer control has suffered damage. By the looks of it. Dimmer control still ain't doing very much. Let's check the voltage on the resistor. So now we're going to check the voltage on the resistor. Let's see what the dimmer control is doing. Dimmer control appears to be burned out. Still not adjusting voltages properly. Still not doing what it's supposed to do there. So now it's either the dimmer control is faulty, or there's still a fault with the radio. Well, let's see if we can find a PNP transistor now to replace TR37. I've got to check that variable resistor. See if that dimmer control is working properly now. Test that now and make sure. Be right back.